In this video, we are going to discuss how to use trigonometry, so how to use sine, cosine, or tangent to find the side length of a right triangle. In order to do that, one of the pieces that you will have to have, tell me now, if you have the sine of an angle, what is sine? What ratio is it? Oh. Sine is opposite of the angle over the hypotenuse. Additionally, cosine of an angle is what? We'd have adjacent over hypotenuse. And if we take tangent of an angle, that is opposite over adjacent. These are facts that we will constantly reference back toward. I'm not going to keep coming to the page over and over, but we will need to use this fact on every single one of the 6 examples we're doing today. All right, so we are going to start here. Looking at this picture, we want to find the unknown side length. Basically, figure out the value of x. How long is that side? In order to do these pieces, we have to start by looking at it and determining which one of these pieces do we have, which are we going to use. One of these 3, sine, cosine, or tangent, will serve as the foundation for solving the problem. In particular, consider the angle. Which pieces do we have based on the angle? Do we have opposite, adjacent, or hypotenuse? Okay, you tell me that you said that we have adjacent. Where is adjacent to 47? I mean, in the picture, where is adjacent? Okay, Kiana, you told me that adjacent is the value for x. Absolutely correct. What other piece do we have? Correct, Josh. We have the hypotenuse, which is a length of 3. Recognizing that this picture is using adjacent and using hypotenuse based on the angle, we have to look at the information and say which one of the ratios can we set up. Does adjacent and hypotenuse set up sine, cosine, or tangent? Cosine. It's cosine. So we will use cosine as the foundation for our equation. The cosine of the angle is equal to adjacent over hypotenuse. Absolutely. That's x over 3. This is the primary skill we have to have. This is the work that's done completely in your head. You have to have the skill of looking at the triangle and analyzing it as I just did to create an equation like this in the red. After you create the equation, solve it. Use your calculator and you're done. So what would we have to do to get x completely by itself? To get rid of divide by 3, we'd have to multiply by 3. So that cancels, and we get exactly what we need. X is equal to 3 multiplied by the cosine of 47 degrees. Put that in your calculator and you're done. So I'm going to run over to my calculator now and say 3 times the cosine of 47. And before I hit enter, please notice my calculator is set to degrees, so I don't need to switch it off of radians and into degrees. 3 times the cosine of 47, 2.04599,508. Let's round that to the nearest tenth. Rounding it to the nearest one decimal place, that's just 2.0. Don't drop the 0 though. When you write it, you should write down 2.0. by having 2.0 written, you show me that you've rounded to the tenths place. If all you do is write down the number 2, I don't know if you rounded to the tenths or to the whole number, to the units. If all you do is write down x equals 2, this looks like, to me, like it could have been 2.4 that you rounded downward to 2. It could have been 1.8 that you rounded up to 2, and I wouldn't know. By writing down 2.0, you provide extra information about how you've rounded correctly. Let's continue to our second example. Start by looking at the sides. Do we have sine, cosine, or tangent? Which comes from, do we have opposite, adjacent, or hypotenuse? Which pieces do we have? Opposite, adjacent, or hypotenuse? We have adjacent, which is where? Based on having 32 degrees, the adjacent is right here. Based on 32 degrees, what is x? It's opposite. So we are given opposite and adjacent, which are absolutely correct, Michelle. That tells us we have to use tangent. So create the equation. Tangent of the angle is equal to opposite over adjacent. X over 13. Correct. In order to solve it, we will have to multiply by 13. And I wanted that in blue so we can see the steps. Multiplying by 13. Let's go to the calculator. 13 multiplied by the tangent of 32. .12, so rounding it, 8.1. And there we go. X equals 8.1. This is all the work that you need. This is what I expect your work will look like when you're doing your homework. When you're working on a quiz, when you're working on an exam, I expect to see the equation get set up, and I expect to see some type of work showing how you solved it. If you include this extra information about identifying the opposite and adjacent, I'm perfectly fine with that. I greatly appreciate you doing that, but it's not necessary. I don't expect to see you writing down opposite, adjacent, and hypotenuse, because if your equation is set up correctly, I know that you identified the pieces correctly as well. Based on this angle, which pieces do we have? Based on the angle of 37, what is 10.3? Is that opposite, adjacent, or hypotenuse? Yeah, this is the hypotenuse. We also have to work with x, which is opposite. Recognizing that we have opposite and hypotenuse, that tells us we need to use the sine, not the sin. Well, sine of what? Sine of 37 degrees equals x over 10.3. Okay, so we'll multiply by 10.3 to isolate the x by itself. And we've got our calculator work now. 10.3 multiplied by the sine of 37. 10.3 multiplied by the sine of 37 degrees. X is approximately equal to 6.2. 6.19. The 9 tells us to round upwards, so we now have x equals 6.2, and we're done. You notice how I have not been writing down any labels for inches, feet, centimeters? Of course, it's because I was not given a label. Please remember, if you are given a label like 10.3 centimeters, your answer should also be centimeters. All right, let's consider our last three examples. Based on our angle of 41 degrees, which pieces do we have? Is x opposite, adjacent, or hypotenuse? That's the adjacent. Remember, the hypotenuse is always across from the 90. Now, recognizing that x is the adjacent with the ugliest A perhaps ever drawn of all time. 4 is opposite. Thus, with opposite and adjacent, which trig identity are we setting up? Correct, that's tangent. Tangent of 41 degrees. No, be careful, dude. It's not x over 4. Remember, opposite over adjacent. Opposite over adjacent gives us 4 over x. When we set these up, this one is fundamentally different than some of the other ones because with our first three examples we had, x was in the numerator, and x was in the numerator, and x was in the numerator.
Will always be in the numerator?
No, the variable is not always in the numerator, as this one shows us. In this instance, we weren't searching for a numerator component, we were searching for a denominator. This is still set up correctly, and I will let you know there are many different correct ways to solve this particular thing. I don't care what algebraic tool you use to solve it. We'll actually go through a couple of them right now, so that way you can pick which one you'd like. Josh, you suggested one method. If you have divide by x, how do you get rid of divide? So one way to do this is to multiply both sides by x, giving us x multiplied by the tangent of 41 degrees equals 4.
So we just divide by.
Since our goal is still to get the x by itself, you're absolutely correct. We have to get rid of that multiplication. And so to get rid of multiplying, we'll divide. Okay, and that then tells us, with multiplication and division canceling, we get what we'd have to type into the calculator. X equals 4 divided by the tangent of 41 degrees. I'm not going to go to the calculator right now and get that answer. This technique that we just did is one correct way to figure out what we needed to do. I have no problem with you doing it that way. I'd like to look at a couple of other ways. Another way that we can algebraically solve this, well, we just spent a crap load of time solving proportions, right? Let's take advantage of something that we've spent a lot of time doing. We could put this over 1, because we know putting anything over 1 doesn't change it. And we've now created a proportion. So we could cross multiply. Tangent times x multiplied by the tangent of 41 degrees, and 1 times 4. Look familiar? We just had it this way. And so to get rid of the multiplication, we could divide. And we get exactly what we needed. X is equal to 4 divided by the tangent of 41 degrees, and it's absolutely valid. Nothing wrong with it. I'll note, this gives us a second technique. It's not the way I prefer to do it. All right. The third way that we can solve this is still based on having fractions. Here is an algebraic rule that, well, it's true, although you may not be familiar or have not worked with it a lot recently. If I have a fraction, 3 over 5, and it's equal to another fraction, 6 over 10. You'll agree that this is true. One algebraic rule you can do with fractions, if they start off as equal, if you flip them both to create their reciprocals, as long as these numbers aren't 0, this is still true. But that's a piece that I can actually do. I have two fractions here. I can flip them and put the x in the numerator. I'll admit this is one technique that I like, although from my experience, most students don't like doing it this way. A lot of students don't like it. Although, if you do it with flipping and taking those reciprocals, how do you get rid of divide by 4? You multiply by 4. And we get exactly what we put into the calculator. 4 divided by the tangent of 41 degrees. I'll admit, this is one way that I like to do it. Most students, from what I've seen, prefer one of those first two methods. A lot of students especially prefer the cross-multiplying proportion method. I don't care what technique you have. In fact, I've had some students in the past that basically just relied on memorization, and they said, well, if I have dividing by my variable, I've had students just memorize a rule that says if it's this part, I have to divide. And so I've had many students who will just write this up and they've memorized what they're supposed to do. Well, that's fine. They still show me setting it up. They still show me what they're going to put in their calculator, and then they actually use the calculator to get their answer. I don't care which method you use. All 4 of them are valid. All 4 of them are correct. And I'd like to go through and actually use the calculator now to get the answer. 4 divided by the tangent of 41 degrees gives us the answer 4.60. So x is equal to 4.6. All 4 of those are good. None of them are my favorite way of doing it. My favorite way of doing these is actually related to the cofunction theorem. In particular, we started off by using an angle of 41 degrees. I don't want to use 41 degree angle. I don't want to use the 41 degree angle. It's that simple. If I don't use 41 degrees, instead, I can figure out how big angle B is. How big is it? Well, it's based on the cofunction theorem. What's the other angle? Just subtracting it off of 90, it's a 49 degree angle. So my favorite method, if this happens, is to actually pick the other angle, giving me 49 degrees. Using that then, 4 is adjacent to the 49 degree angle, and x is opposite the 49 degree angle. You'll notice by picking the other angle, opposite and adjacent get flipped around. That's what we were discussing with the cofunction theorem. Opposite and adjacent are just different names depending on which angle you're using. So my favorite way is to set this up as tangent of 49 degrees instead of 41. And then it's x over 4. Because x is opposite the 49 and 4 is adjacent to the 49 degree angle. And this is much simpler to solve algebraically. All I have to do then is multiply by 4, and it's the same type of thing as what we were doing with the first ones. 4 multiplied by the tangent of 49 degrees. And we'll go to the calculator and verify 4 times the tangent of 49. I have the exact same answer. 5 different ways of getting the answer. I don't care which one you use. Pick the way that you like best. Pick the one that you feel is easiest. When we're working in class, I will do whichever technique you tell me to use. Whichever one people shout out with, whichever one people shout out, that's the one we'll use. So let's continue. How is it going to get set up? Well, which pieces do we have? Based on the 57-degree angle, x is the hypotenuse. And 10.8, that's opposite. So I could set this up. Sine of 57 degrees equals opposite over hypotenuse. And so we've set it up correctly. Now, how do you want to solve it? Tell me what to do. Okay, Rochelle said she wanted to do the reciprocal, and since she was the first one who went out with it, that's the one we're going with. First person who picks what they want, that's the one we're going with. Taking the reciprocal of both sides, we'll multiply by 10.8. And so 10.8 divided by the sine of 57. Let's go to our calculator and get the results now. 10.8 divided by the sine of 57. 10.8 divided by the sine of 57 degrees rounds to 12 and 9/10. So 12 and 9/10. Here's our last example for this video. What do we have? Okay, based on the 50.1 degree angle, 5 is what? 5 is adjacent, and x is opposite. So opposite and adjacent tell us to build tangent. Tangent of 50.1 degrees is equal to x over 5. And I like the fact, Kiana, that you didn't get caught up. The last two examples had the variable in the denominator, but you didn't let that pattern distract you. We actually need to look at it and see which one is opposite, which one is adjacent, and not just assume the variable will be in the numerator or denominator. Okay, so to get the x by itself, we'll multiply by 5. And so 5 times the tangent of the 50.1 degree angle. Okay, 5.6. And the students are telling me it's coming out to be 5.97. So 5.97, if we're rounding it to the nearest place right here, the 7 tells us to round up, which would then carry over, and we wind up with x is approximately equal to 6.0. And so we're done. These processes are the foundation behind almost everything we're doing for standard number 8. Standard number 8 is mostly about finding side lengths, figuring out angles. This type of process serves as the foundation for almost everything we're doing with similarity and right triangle standard number 8. Please note the format. You have to look at the picture and recognize what pieces you're given. The pieces you are given help you to build the equation. Once you have the equation, you solve it.